We're talking about covalent bonds, and the first one we're going to talk about are single covalent bonds. So a single covalent bond is when two atoms share one pair of electrons. So this is a carbon atom, and you'll notice it has 1, 2, 3, 4 electrons in this outer shell, and to be stable it needs 8. So it might share one with hydrogen. Each hydrogen atom needs one more electron to be stable. So if you look at this inner energy level, you can fit 2 electrons. Here's hydrogen. It only has 1 electron when it's neutral, and it needs 2 electrons to be stable. So this one could share with this one. And we'll take a look at what that looks like. Here are the single covalent bonds. So these two are a pair, and they'll spin around both atoms. And these two are a pair, and they'll spin around both atoms. So these are a bunch of single covalent bonds because the two atoms are just sharing one pair of electrons. So each of these, I had said that already, needs one more electron. These need 4. And so 2 electrons are shared between each pair of atoms. Each atom now has a filled outer energy level. Wow! So what that means is that this hydrogen will be stable with 2 electrons, so these two will end up going around both of them, but it um, makes it stable. So this energy level in effect has 2, even though they're not spending all their time here, not even half their time probably, but even though they're not spending all their time here, it's still considered 2 electrons, so that's stable. Carbon has 1, 2, 3, 4, 5, 6, 7, and this one makes 8. So that has 8 electrons now in its outer shell, and it's filled too. How many more electrons does oxygen need in order to be stable? So we were just talking about carbon. Now we're talking about oxygen. Oxygen naturally has 1, 2 in its first shell. 1, 2, 3, 4, 5, 6, 7, 8 electrons in total, but 2 of them are in this first energy level, so that's 6 electrons out here. It needs how many more to be stable? It needs 2 more. This one will need a pair, and this one will need its mate as well. So now we're going to talk about double covalent bonds. So double just means 2. So if you look at oxygen, it's got this one that's missing its mate and this one that's missing its mate. Same thing with these. And so these two will end up being shared. And these two will end up being shared. And that's going to give us our double covalent bond. There are 2 pairs of electrons that will be shared. Each of them needs 2 more electrons, each of the atoms. And so what you end up getting is we're not looking at the inner shell, so this picture is not showing this inner shell, but it's showing you the 4 shared electrons. So these are one pair of shared electrons, and these are another pair of shared electrons. So this is the way you draw that, oxygen with 2 lines. That means a double covalent bond. So each atom now has a filled outer energy level. Here's a triple covalent bond. Nitrogen has, I don't like the way this is drawn because these two can actually be a pair. So nitrogen has 2 electrons in its inner shell, and it has 1, 2, 3, 4, 5 electrons in its outer shell. These two are paired, and these are free. Maybe another way to draw that, maybe a better way to draw that. Here's nitrogen, and it's got 2 electrons in its first shell, and then it has 3, 4, 5. So 1, 2, 3, 4, 5. This is really a better way to show it because you've got these 2 that are paired, and these 2 are the paired ones, but they're not near each other in this. So these 2 are paired. That means they're in the same orbital, these 2, but the others are unpaired. So these 3 need to become paired. So 6 electrons are shared, or 3 pairs of electrons are shared. So I'm going to draw that for you. What it's going to end up looking like is these are going to be shared, these are going to be shared, and these are going to be shared. So the way we draw that, sort of the shorthand form, is nitrogen is forming a triple covalent bond with another nitrogen. And this is what's in the atmosphere. About 80% of the atmosphere, maybe not quite, but almost 80% of the atmosphere is this. It's nitrogen, which is N2, and it's the most common gas in the atmosphere. And it's got a triple covalent bond. Very, 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 very strong. Oh, orange. Not very nice, is he? And he always glitches my computer. Okay, so we'll watch one quick video and we'll be done.
Ionic bonding occurs between two atoms when one of the atoms has sufficient strength of attraction to remove an electron from the other atom.
So I don't care if you know
A
ionic
sodium
bonds,
atom has one valence electron,
but you do need to know
and a
ions.
stable energy level below containing 8 electrons. A chlorine atom has 7 valence electrons. If the atoms collide with sufficient energy, the chlorine atom will remove the electron from the sodium. The sodium atom loses its only valence electron and becomes a positively charged sodium ion. The energy level below now provides sodium with its stable octet. The extra electron completes a stable octet for chlorine, which becomes a negatively charged chloride ion. Covalent bonding occurs when neither atom has sufficient strength to completely remove the other atom's electrons. The atoms share electrons, and both atoms achieve a stable outer energy level. A hydrogen atom with one valence electron needs one additional electron to complete the first energy level. An oxygen atom has 6 valence electrons and needs 2 additional electrons to complete the second energy level. As the oxygen and hydrogen atoms collide, covalent bonding is accomplished by the sharing of electrons. By sharing an electron pair with the oxygen, the hydrogen completes the noble gas configuration of helium. By sharing with the hydrogen atom, the oxygen atom now has 7 electrons in its energy level, still one short of the stable octet condition. A stable octet for oxygen can be completed by sharing an electron with another hydrogen atom.
So the covalent stuff is what's important there. For the ionic bonding, I don't really care if you know what ionic bonding is, but you do need to know what ions are. And for covalent, they just share electrons. And I think that's it for this. Bye!